In this part of Chapter 7, we're going to find unknown forces using the concept of equilibrium. So what equilibrium means is that, let's say that you have a crate, and you have multiple forces acting on that crate. So the crate is going to have a mass m. So let's say that there's a force F1 pulling it backwards. So minus F1. And there are two forces pulling it forward. So F2 and F3. So in order for this system, we're going to want this system to be balanced or in equilibrium. So what that means is that however much force you have in one direction, they all have to balance in the opposite direction. So actually F1 then should be the same length as these other two forces so that they balance. Combined, the combined length of F1 should be the same as the other two in terms of their length, so that they're balanced. And again, we're assuming that there's no motion, so acceleration is going to be 0. So from Newton's second law, what that means is that the total force acting on that crate has to be 0. Or you can also write that as the net force acting on the crate has to be 0. And in this picture, you would write it like this. So you have the total force is going to be F1 acting backwards, so minus F1, plus F2 acting forward, so plus F2, and plus F3 acting forwards, and then set that equal to 0. And then you can solve any one of these or you can solve one of these given the other two. This simulation is meant to introduce us to the rotational version of a force, which is called a torque. First thing to notice is that if I tried to exert a force along the radius of this disk, not much happens. But as soon as I have any component of a force that's perpendicular, you notice that there the disk starts to move. And we could just make this thing speed up here. So whenever you exert a force on a disk perpendicular to the radius, you're going to make it accelerate, and this rotational kind of force, we're going to call that torque. And now let's apply the brakes. You notice again here that the brakes apply a force perpendicular to the radius of that disk. And so this is going to represent a torque, a force that acts perpendicular to the radius of a disk that can make it either speed up or slow down. Before we discuss torque, let's go back and look at forces. So let's say that this is the floor and there's a crate here. And let's say that you apply a force at the center of the crate. What that's going to do is it's going to cause the crate to move in a straight line. So it'll wind up over here. But let's see the rotational analog of a force then. So imagine that you have a disk and it can rotate about the center point. And let's just say that you apply a force right at the edge of the disk. And you're going to apply that force perpendicular. So you apply perpendicular force, and the force is applied at the edge of the disk, and the disk has a radius r. What that's going to do is it's going to cause that disk to spin around and rotate. So the force to make it rotate, we're going to call this the torque. And it's going to be given by this variable tau. And so the equation is the torque is going to be the radius that the force is applied at, multiplied by how much force you apply. And I like to use a perpendicular symbol just to remind me that the force has to be perpendicular to the radius. And so torque is going to have units of meter times newtons, or Newton meters. It could also be measured in pounds times feet. So the other thing to consider with forces, a positive force means you're pointing towards the right, and a negative force means you're pointing towards the left. So here also we're going to introduce positive and negative torques. And for this we're going to use our right hand in something called the right hand rule. So the whole idea is that if you apply a force that perpendicular to this radius in such a way that it's going to make this thing rotate counterclockwise. So it's going to rotate in this direction. That's the same way that your hand would spin. So if you place your hand right above the image, so I'll try to draw it here. So looking down from where you are, your hand, your right hand, would want to do something like this. It naturally wants to curl in that direction, which is counterclockwise. So because of that, we're going to say that a counterclockwise torque is going to be positive. So if the torque is counterclockwise, or CCW, then that's going to imply a positive torque. And vice versa, if the torque then is clockwise, then that's going to be negative. So if you have a disc, and you apply again a force at the edge of the disc, but this time you apply the force in this direction, what that's going to do is it's going to make that disc rotate clockwise. It's going to give it a clockwise torque. And because it's going opposite to the way your right hand naturally wants to move, we're going to say this is going to be a negative torque. So clockwise rotations are going to have a negative torque.